Hello students, welcome back. The topic that we are going to study today is central of tendency. Now in my earlier videos we were discussing about the frequency distribution, that how to organize a data into a frequency distribution. It is good when we are summarizing the data, but it is not very useful when we compare two or more distributions. So for that we need averages or central of tendencies values so that we can compare between two or more distributions. So let's get started. First of all, in measure of central tendency, as I told you that we compare averages. So first of all, we need to know that what averages are. So an average is a single representative value of the data. Alright, and most of the value have a tendency to lie around it. Now that means the central position value of the data is known as average. Alright, so that means out here that it's written that central of tendency is sometimes called measure of central location, because these values are the center values, the mid values, so they're called averages, and they're also known as central location values. Now first of all, we're moving on towards the type of averages. Okay, so the most common types of averages are arithmetic mean or mean, median, and mode. Now these averages are also called the first order averages. So these are the basic averages, the most commonly used averages, that is mean, median, and mode. In this video we will be learning about mean first, that how to calculate mean when different types of data is given. Alright, by types of data I mean that we are going to distribute it into three parts, right? Like in case 1, that is when simple random observations are given. Case 2, when a simple frequency distribution is given, that means with each corresponding observation, there is a corresponding frequency to it. And the third, that is case 3, refers to the grouped data in which the data is organized into classes. So let's get started. Alright, first of all, the arithmetic mean. Okay, so the mean or average is the most popular and well-known measure of central tendency, and it can be used with both discrete and continuous data. Okay, so first of all we need to know that how mean exactly is calculated. So mean is basically represented by x bar, and it's calculated as the sum of all observations divided by the number of observations. So arithmetic mean basically means the sum of all observations, that means summation x, divided by the total number of observations, which we will be representing it as n. Okay, so here are some formulas for group and ungrouped data. Now first of all, to calculate mean for an ungrouped data, the formula is x bar equals to summation x divided by n. Now the summation x means that x represents the number of observations. Alright, so the summation x means sum of all the observations, and n represents the number of observations, that how many total observations are given in the data. The grouped data. Alright, so the formula for group data is x bar equals to summation f of x divided by sum of f. Now as I told you that in group data the intervals, the organization is in such a way that we divide the data into classes. Alright, so for that, when we are using this formula, this does not means observation out here. It stands for midpoint. Alright, and f stands for frequency, that means the total count of that class. Okay, one more thing also, this formula is used for case 2 as well, that is simple frequency distribution. Alright, so we will be using the same formula for simple frequency distribution and for grouped frequency distribution. Moving on, we'll first of all start with an ungrouped data example. Alright, in a batch of 10 students, the marks obtained by them are as follows. Now these are the marks that are obtained by students 7, 8, 5 6 7 5 5 4 6 7. I have also write it down in a form of table, and I have just calculated total, that was my summation x, that is equals to 60. Now if you just add all these numbers, the total is 60. Since the total number of observations were 10, so 60 according to the formula, that is x bar equals to summation x divided by n, which is equals to 60 divided by 10 will gives you 6. So out here mean value is 6. So for ungroup data, what we going to use, or what the thing is out here, that for ungroup data there is a type where simple random observations are given. As you can see out here, there are only random observations from let's say 5 to 10 observation. In this case they were 10, and they ask you, there is no frequency distribution, there is no tabular form in which the data is organized. They just simply gave you the values and they are asking you for the mean. So for that type of data, what we are going to do is they're going to add all these values and divide it by the total number of values, so that we'll get a so that after that we'll get mean value, that is 6 in this case. Alright, so there's another example. For the given data, find the arithmetic mean. Now this is the data given: 2 7 5 minus 4 0 3 11 9 minus 2 and 1. Alright, and they have asked you to find out the arithmetic mean for the following data. Now since n is 11 and the mean formula is summation x divided by n. Now what we are going to do is we're going to add all these values: 2 plus 7 plus 5. Now this is minus 4, right? So plus into minus will gives me minus, plus 0 plus 3 plus 11 plus 9. Since it says summation, so the value itself was minus 2, so plus into minus will gives me minus 2 plus 1 divided by 11. Now after solving it, the final mean that we get is 3.2. Now you just solve the numerator, you divide it with the denominator 11, and you'll get this final value, which is 3.2. Alright, so there's another example. So if the mean of the following numbers are 17, find the value of k. Now in this type, in this example, as you can see that there are 5 values in total. Alright, and we are asked to find out this one particular value, which is represented as k. Alright, and they have told us that the mean value of all these numbers including k is 17. And we are asked to find out the value of k. So since the formula for mean is x bar equals to summation x divided by n, what we are going to do is that we know the x bar value, as it says that the mean of the following number is 17. So you're going to substitute 17 in this place, alright, as x bar, because mean is given as 17. And let's just look at it. Right, alright, and n was given as 5, mean value is 17, and summation x. Now what we're going to do is we're going to add all these values and write it down the way we used to do it for summation x. Since these all are my observations, my x, my observations, so I'm just adding all these observations: 12 plus 18 plus 21 plus k plus 30. Now what I'm going to do is that this 5 is now in the denominator. If I just multiply it with this number, alright, so 17 multiplied by 5 will give me 85, right? And 12 plus 18 plus 21 plus k plus 13 are written as it is. Now in the next step, what we are going to do is we're going to add all these numbers, that is 12, 18, 21 and 13. Alright, so the answer I got is 64 plus k, right? Now since we need to find out the value of k, after this step, just one step is required to find out the value of k. We're going to shift 64 since it's plus 64, and we need to find out value for k. So k will be equals to 85 minus 64, which will be equals to 21. Alright, so that is how you find out a particular value. Let's say if mean of the numbers are given and you're asked to specifically if you're specifically asked to find out that one number. Alright, so this is how you do it. So if you want to verify your answer, what you can do is you can substitute this 21 at this position and add all these numbers and divide it by 5, and you'll came across that you'll get the mean, which is equals to 17. Alright, so what you're going to do is substitute this 21 in this position and calculate its mean. Okay, so 12 plus 18 plus 21 plus 21 plus 13 divided by 17 will gives you divided by 5, sorry, will gives you 17 as mean. Okay, so moving on, this is basically the case 2, which is mean for simple frequency distribution. Now compute mean for the following data. Now this is the mean, this is the table, actually this is the data whose mean is asked out here. Now as I told you in my earlier videos, that simple frequency distribution means that there is observation given, and to every observation there is a frequency given. So as you can see out here, there is observation 10 with frequency 6, there is observation 12 with frequency 6, there is observation 14 with frequency 8, and there is observation 16 with frequency 9. And so we know we will be using, as I told, that we will be using the same formula for simple frequency distribution, the way we used to the group formula that I told you earlier. We're going to use the same formula to find out mean for simple frequency distribution. Alright, okay, so there it is. Now as you can see out here, x was given as it is. These were the values that were already given in the question, and f was also given in the question. Summation f was equals to 29. I just add all these values and the sum I got is 29. Now how do I get this column? So the formula for mean for simple frequency distribution is x bar equals to summation fx divided by sum of f. Now sum of f value is here, that is 29. Alright, and for fx, what we are going to do is we're going to multiply these two values. X is my observation and f is the frequency. So 10 into 6 gives me 60, 12 into 6 is 72, 14 into 8 is 112, 16 into 9 is 144. Alright, so this is how I get my f of x, f into x, sorry. So fx is like 60, 72, 112 and 114. As formula says that you need added values of fx, that is summation fx divided by the sum of f. So the total value, that the sum of fx is 388. Alright, so x bar equals to summation fx divided by sum of f. 388 divided by 29 will gives me 13.37. So for these type of cases, for these types of scenarios, when a simple frequency table is given to you, we will be using the same formula that we will be using for group frequency distribution, that is x bar summation fx divided by sum of f to find out mean. Alright, in this particular scenario, x represent the observation itself, because there are no classes. As I have written earlier, that for group distribution, x represent midpoints but not classes. Alright, because their classes itself is given in interval forms. But out here, x is directly representing the observation, because there are no classes, so we don't need to find out the midpoints. Alright, so x for this case is the observations given, f is the frequency, and after just multiplying f and x for each value, we get the total, after that we'll get the total value, that is summation fx divided by sum of f, and that's how we'll get mean value, that is 13.37. So moving on towards the last topic for mean, that is grouped data, that how to calculate mean for group data. Now the example says that compute arithmetic mean, or sometimes we write it as AM, for the from the following distribution. All right, so this is the distribution given. The class intervals is 2 to 6. The observation for this particular class is 3. 7 11, 7 to 11. The frequency for this class is 4. So in this particular case, what we see is that the data was organized or is organized into classes, and to every class there is the frequency count. All right, and we are asked to find out mean for this data, which is called grouped data. Now solution. Okay, so we're going to use the same formula, that is summation fx divided by sum of f. Now but for x, this time x should be the midpoint. Why? See, for class interval, as you can see that the values start from 2 till 6. Now if you're calculating mean, all right, and x represents the observation as we did in simple frequency distribution. So when classes are given, we don't know that which number to select, right? 2 should be selected, 3, 4, 5 or 6. So for this thing, what we used to do is that we take the midpoint of this class, that is 2 plus 6 divided by 2. That's how you get the midpoint. And after you get all the midpoint, now this midpoint becomes my x. All right, so for mean, whenever grouped frequency distribution is given and you're asked to find out mean, you need to calculate midpoint first. All right, because midpoint is basically the x. For in this case, the formula was summation fx divided by x divided by summation f, and x represents the midpoint for grouped distribution. So the first thing is that whenever the grouped frequency distribution is given, we are going to add this column, that is midpoint column. I'm going to calculate all the midpoint, and after that we will be calculating f of x. Now 3 into 4 is 12, 4 into 9 36, 11 into 14 154, 9 into 19 171, and 3 into 24 gives me 72. Okay, so now the total frequency, if you just calculate, if you add all these numbers, 3 plus 4 plus 11 plus 9 plus 3, it will gives you 30. And if you add all these numbers, the fx part, 12 plus 36 plus 154 plus 171 plus 72 will gives you 445. So that is how the summation f is calculated. Summation fx is calculated for grouped frequency distribution. So the formula was x bar equals to summation fx divided by sum of f, and since fx was 445 divided by 30, it gives me 14.83. all right, so that is how you calculate mean for a group distribution. If you just give a review, if I just give a review of all the things that we have done in mean, see, for simple random observation, the formula is summation x divided by n. That is, you add all the observations and divide it by the total number of observations given. For simple frequency distribution, we're going to use the same formula, this one, that is x bar equals to summation fx divided by sum of f. X in simple frequency distribution means the direct observation, because if you just remember what exactly simple frequency distribution look like, it's like a table in which for each observation there is a frequency given to it. There is a frequency corresponding frequency count written next to it. All right, so for simple frequency distribution, what we are going to do, we're going to multiply frequency with the observation itself, and for each frequency distribution and for each observation. After just calculating this parameter, we're going to add it, that is summation fx. We're going to take summation fx value and divide it by the total frequency, which is the sum of f. For grouped frequency distribution, we are again going to use the same formula with a slight difference. The difference is that this time this x actually represents the midpoints, because the data is given in the form of classes, alright, and we are going to take midpoints first. That will be represented as my x, and after that we're going to multiply each x, each midpoint, with the corresponding frequency to find out the total fx. Alright, so after calculating the summation fx, you just put it in the formula and you will calculate the mean. So I hope that you have understood that how mean is calculated for all three cases. Thank you.